Okay, so anyway, this to get started here. This is a simple scatter plot. So within the matplotlib.py plot, there's this scatter function, and you can basically provide it to variables. The first one will map to the x-axis, the second one will map to the y-axis. This is the same thing, just using a different structure. Note that these are being read in as a data frame, pandas data frame. So we looked at this last time, so I can do dot the column name, or I can put it in square brackets in quotes, just the column name. So either way would work. So anyway, this will generate the plot and save it to this object, and then the dot show function will plot it. So since I did the inline up here, I don't need to back up there. If it works correctly, then that means that it should just plot right below it there. So let's run that and see what happens. There we go. All right, so this is a basic plot. Note that we haven't really done. It doesn't have a lot of the attributes that you'd want it to have, right? It doesn't have title or axis labels or anything, and that's okay. We're gonna look at that later. What I'm just trying to show you now is the basics, right? Okay, so again, our x-axis is the elevation, and our y-axis there is the temperature, the mean across the county, or the mean annual temperature. And we can see kind of a negative correlation there, so, or inverse correlation or whatever. So higher elevations tends to be associated with colder temperatures, right? Okay, so anyway, that's a simple scatter plot. So all I had to do is feed it two continuous variables and then get the plot back. This is a histogram. So histogram is showing the distribution of one variable. So now we only have to feed it one argument instead of two. So again, we're just doing plot.hist now as opposed to plot.scatter. And then, and again, we're just showing it. All right, so this is for the my rating. So this is kind of the distribution of the rating. So we can kind of see the central tendency. We can see that there's kind of a longer tail out towards low ratings than there is out towards high ratings, and generally the data are skewed more. Well, we are centered kind of around the 7 range, right? Rating of 7. So anyway, it just kind of gives you the sense of the distribution of the data. For example, this is commonly used whenever trying to determine if data are like multimodal or really skewed or not normally distributed, if you're worried about that. Okay, so anyway, those are just two basic plots. Okay, one thing that initially is confusing, at least for me, for Matplotlib, is the concept of like subplots. So in the like kind of lingo in Matplotlib, you can have a plot or a figure, which is basically like a space, like a layout space, a graphic space. And then inside of that space, you can have subplots. You can store different plots. And they actually generally call subplots axes, which is, in my mind, really confusing because in the world of graphs, we think of axes as like, that X and Y axis. But when we're talking about subplots, basically an axis is a subplot within a larger plot or figure. Okay, so just to show you how that works is first I'm creating a plot that has subplots. So to do that, I do plot.subplots and then 2. So basically this is the numbers of rows and columns. So I basically have 4 positions within the plot. The reason why there's two variables here is because it produces 2 different arguments here, or 2 different variables. So we have the figure and then the axes. Okay, so then once that's created, then I can put something in each of those positions. And since, again, this is a 2x2 matrix of rows and columns, they're indexed from 0 to 1. So this would be row 1, column, the first row and the first column, the second row and the second column, or the first column, first row, second column, second row, second column, right? So all I'm doing is I'm just replicating this histogram using a different bin width, which is like how wide each of the groups are. And then I plot that. So let's say have a look at that and see if it makes sense. Okay, so row 1, column 1, that's this with a bin width of 5. And then this is it with a bin width of 10, so this is row 2, column 1. And then this is your row 1, column 2, bin width of 15, and then row 2, column 2, right? So anyway, this is this indexing to write and call subplots. You'll see that a lot throughout these examples, and that's just how Matplotlib works. If you're going to have multiple plots. Okay, cool. So anyway, that's an example of that. Note that again, just not really the code, but just looking at the plots. I mean, the trends here are pretty similar, but you know the level of detail changes based on the bin width. There's not really a good way or like a default way to decide like what the bin width should be necessarily. Generally, you're kind of a balance between like having a pattern that's just really generalized and doesn't really tell you anything to just seeing a lot of noise. I personally think in something like this, like this bin width of 10 or 15 is useful, but again, it's just kind of your opinion, and so it's not a hard number there. Okay, let me show you next a box plot. Okay, so a box plot is used to show the distribution of a variable. Let's just print it. I mean, it only requires one argument here. So we're just printing the county level median income, and this is from that county's data set. Okay, so this just gives you like distribution. So the value here is the median income, and we basically have the median in red, the first quartile, the third quartile, and then the range. Now, if there are values that I think the default is if it's more than 1.5 IQR higher than the third quartile, or 1.5 IQR interquartile range, which is basically this range from the first quartile, then it's plotted as an outlier. So there are some points up here that are counties that have like high median income. So those are plotted as dots as opposed to stretching the range all the way up. But I mean, technically that would be the full range. Different graphing software, by the way, will do that differently. And sometimes there are settings, or additional arguments you can specify. In fact, this is a good time to look at that. So let's Google Matplotlib Box Plot. Okay, so matplotlib.pyplot and then box plot. And let's see what arguments there are that you can set. Okay, so parameters. So it takes an array or a sequence of vectors. So that's basically the data that we fed it. Notch. So whether to draw a notch box plot. True, or a rectangular box plot, false. So let's just play with this for a minute while we're just to see what some of these different settings do. Okay, so I'm going to put in here, oops. So I'm going to add in here, notch is equal to true, and see what it does. So yeah, so it adds a little notch there around the median. Then we have SYM, the default symbol for flyer points. An empty string hides the flyers. If none, then the flyer default to B+. More control is provided by the parameter. Does that mean let's see what it does. I think that's saying that if you set this to none, then that means it's not going to draw the points. No, I guess it didn't. I'm not really sure what that did, to be honest. The next argument here is vertical, and then set that to true. I think that's the default. Oops, I got rid of the parenthesis there. I think if we set this to false, it'll draw on its side, I believe. Yeah, there we go. yeah, anyway, so there's a bunch more arguments. I was gonna see if there are any options here for outliers. Okay, I guess they're calling them flyers in here. So the default symbol for flyer points an empty string hides the flyers. If none, okay, so none actually didn't hide them. I just did it wrong. That's why it didn't make sense. So if you do SCM is equal to an empty string, then it should not plot the outlier points. Well, what it's calling outlier points. Anyway, so there's obviously settings that you can change, and the documentation will help you with that if you're not sure what the options are. Okay. All right. Again, this is showing some stuff with subplots. So now I have, I'm creating a 3x3 matrix, so that's a total of 9 plots, and I'm just going to plot a couple different things. So I have a box plot for the distribution of percent forest cover, percent of the precip data, the elevation, and the temp, and then I have scatter plots to look at the correlation between elevation and temperature, and elevation per percent forest cover, and then histograms for a few of the continuous variables. Again, this isn't going to make a plot that's great. The point is that it's just showing you how these axes work, right? So anyway, there's those different distributions there. Okay, so that's the basics of graphing, right? So basically the key thing to start off with is, what type of graph are you producing? And that's going to generally depend on, what it is that the type of data you have and what you're trying to show. So if you're just trying to look at like the distribution of a single continuous variable, you may want to do, a histogram or a kernel density plot. If you want to look at the correlation between multiple continuous variables, it'd be like a scatter plot. If it's a time series, it could be like a line plot. Anyway, so we'll look at some other examples as we move on with different types of plots.